All right, welcome to section 4.3 where we are going to start to have some real fun. We are going to be finding areas using definite integrals, and that means that we are going to be doing what we were doing in the previous section, except instead of doing very lengthy approximations, we are going to go ahead and actually find the exact area using calculus using the integrals. So here is the equation that we're going to use. If you want to look more into this, this is sometimes called the fundamental theorem of calculus part 2. The idea is if we've got some function and we have some interval a to b, and we want to know what is the area of this part of the curve. What is the area of this part of the curve from a to b of my function? Okay? It turns out that that area will equal the integral from a to b of f of x. And so notice that a and b are just x values over which we are integrating. This, in turn, is equal to the antiderivative function evaluated at b minus the antiderivative function evaluated at a. And it's just so beautiful and simple. I just love it. As long as we can find our antiderivative of this, our integral of this, we can use this equation to find the area. Let's do a couple examples so you can see how to apply this formula. Our equation is y equals 6. The antiderivative of this equation is going to be capital F of x is equal to 6x. So here is how you would write down all of the steps. We want to find the integral of 6 from 0 to 3 dx with respect to x. That's like kind of what this dx means. It's the differential. It means with respect to x. So we know that the antiderivative is 6x. So this is equal to 6x evaluated from 0 to 3. So this bar means that we're evaluating it from 0 to 3. Notice that we're doing this instead of doing the plus c because we know what function we're talking about. We're talking about the function y equals 6. So that's the function we're talking about. We want to find its area with the x-axis. And so here it is. This is just a fancy way of writing this part right here. So we just evaluate it from 6 times 3 minus 6 times 0, and we will get our answer. This piece right here is just 0, so the final answer is just 18. So to understand what we just did, we had the equation y equals 6, which is a horizontal line, and we found the area from 0 to 3, and not surprisingly, the answer is 18 because that's just one rectangle of width 3 and height 6, so the answer is just 18. Of course it is. Why are we doing this? Well, we're doing this because this equation works for everything, as long as you can find the antiderivative. Let's do the next one. We want to find the area of 4x and the x-axis from 1 to 3. That means we're doing 1 to 3 of 4x dx. That's, excuse me, that's the integral from 1 to 3, our two x values, of the function 4x. All right, let's not make a mistake this time. This is going to be 2x squared. And so sometimes you just have to look at it a little bit and see if you can find the antiderivative. Remember, what's nice about this is you can always take the derivative and check your answer. So take the derivative of 2x squared and you get 4x. Another way you could have got there is by doing 4x. The antiderivative of that is 4x squared over 2 because the 2 comes down and cancels, and 4 divided by 2 is 2. So just play around with these integrals a little bit. If you really get stuck on one, let me know and I will tell you what it should be. So integral of 4x is 2x squared, and we are going to evaluate it from 1 to 3. So that means plug in 3 for our x value first, and then subtract 1 for our x value second. You just copy paste this function twice. First you do 3, then you do 1. Top bound first, then the other one. That's going to equal 3 squared is 9 times 2 is 18, minus 2 is equal to 16. That's the answer. So what we just did, that's the area. We just found the area of the line 4x, which kind of looks like, oops, actually it would go through the origin, sorry. 4x would go through the origin. We just found the area from 1 to 3, so we just found the area of this trapezoid, which is 16. Now this is where this really becomes useful. Let's find the area of x squared and the x-axis from 1 to 4. That's the integral from 1 to 4 of x squared dx. This is an easy one. It's just going to be x cubed over 3. Hopefully by now you're getting the hang of doing this. We evaluate that from 1 to 4. That means plug in a 4 first, then plug in a 1. So I just put in my 4. Then we had a subtraction because that's the formula. Plug in your 1, and there you go. So that's going to be 64 over 3 minus 1/3 is 63 over 3, which is equal to 21. That's just incredible to me. If we do 64 minus 1 is 63, and that's just 21, what we just figured out is this. We know what x squared looks like. And what we said is, what is the area from 1 right here to 4 right here? And we just figured out that that area is equal to, even though it's a curved space, that area is equal to exactly 21, which I think is frankly just incredible. We'll take a stop here, and in the next video we'll do some more examples.